Hello students, this is next lecture. Now here from here onwards, I will be doing the preparations of the phenols. So there is one method of preparation. First method of preparation of the phenol. I'll write the heading. Preparations of phenol. So first method is from hello arene. Okay. First method is hello arene. Uh, this method is also known as a Dawes process. Okay, Dawes process. Those who are answering a competitive exam, for them, knowing this name Dawes process is important. Otherwise, from Halloran, if you are answering a Goa board, then it will be mostly the questions is straight. Okay, directly. This is very specific reaction only for the preparation of the phenol. To start with, it is said it is a haloarine, right? From haloarine we are doing. So here I'll start with this chlorobenzene. I'll take a chlorobenzene. Okay, and I will treat this with a NaOH. Okay, how it is, why it is, let us learn this later. So I can show it this way or I can show it on arrow. I am treating this with NaOH at temperature, very high temperature, 623 Kelvin, and a pressure of 300 atmosphere. Why we require such a high temperature and high pressure? I will explain you in the part of the mechanism of this reaction. First, let us understand what is the reaction. Then this is what the next product, okay, intermediate product we are going to get, O Na plus and minus, and further in the presence of acid, what we are going to get is the phenol. Means here the OH is going to come. Now, one simple reason what I can say is that over here you must be thinking why 623 Kelvin and 300 atmosphere pressure, so much of the temperature and so much of the pressure. See, finally it is this bond is breaking and the OH is getting substituted. If we have understood the first chapter haloalkanes and haloarine, there we have understood that this bond, carbon halide bond or any bond which is present on a benzene, is very difficult to break. Okay, if I compare a carbon halide bond to that of the alkane, okay, let's say this is a alkane, where the hybridization is sp2. Okay, where the hybridization is sp2. Let's say this is the alkane, and if there is a bond in a benzene, okay, if this is the bond in the benzene, this is also halide. This, to break this bond we will require more energy compared to this. Okay, this is easy to break. That is the reason we require very high temperature and high atmosphere. The role of the acid I'll explain you further in the mechanism, but these are the things what is required for the preparation of the phenol from a haloarine. And the haloarine we have chosen over here is a chlorobenzene. In short, what I can write is some theory part I will write, how to remember this. A chlorobenzene is treated with fused. Okay, chlorobenzene I will write here. Benzene is fused with NaOH. Okay, temperature, at high temperature and high pressure, phenol is obtained by, further you can say this, phenol is obtained by acidification acidification of sodium phenoxide ion. Okay, acidification of sodium phenoxide ion. Now here, um, this is a chlorobenzene. This is a chlorobenzene. This is a sodium phenoxide, and this is final product is phenol. So this is about this is what I have done is a description of the whole reaction. Now let us go into the mechanism. See, mechanism, if you want to learn, it is not so important as long as you are answering a Goa board exam or a state level exam. um, but if you're answering seriously any NEET or any competitive exam, NEET, JEE exams, then mechanism is really important. Try to see how the things are happening in the reaction mechanism. It will improve your perspective about your organic chemistry. It will make your reactions or memorization, okay, memorization will become easy. Okay. Finally we have to memorize the reaction, no doubt, but sometime it should not lead to any confusions. Okay, so knowing some little thing about the mechanism also helps a lot. This process is also called as a dose process. So I will write the mechanism. Okay, I'll write here mechanism, that is Dawes process. Other name for this reaction is Dawes process. Preparation of phenol from haloarine. Okay, first of all, I'll take a haloarine. Okay, I am taking the haloarine. This is the haloarine. That is chlorobenzene, which I have taken over here. Now, there is a base which we are adding a base, NaOH. Okay, this is what the base we are adding, NaOH. Now, this is a source of OH minus, right? NaOH is a source of, it is a source of OH minus ion. Now this is a very strong base. The role of this base, this is to abstract a hydrogen. Now there is no any other hydrogen except these hydrogens, right? On every carbon there is a hydrogen, right? On every carbon there is a hydrogen. Now the thing is that this base is going to remove only this hydrogen. See, it is not that easy to remove or break this bond from the which is connected to the what I can say a benzene ring. It is not that easy since the temperature, if you see in the reaction, it is temperature was very high and the pressure was also very high. This reaction is possible. Otherwise, this reaction breaking of these bonds is not so easy. Now it is abstracting this hydrogen because it is not having any other option. Let's say there was one more hydrogen like this. If there was a this type of group, then this base would have abstracted this hydrogen because this is very easy to remove, right? So here, since there is no option for this, it is abstracting this hydrogen. If this is abstracting this as a H plus, this is minus, it is abstracting this as a H plus, means there are electrons over here, right? This one bond is made up of electron. So this hydrogen is going to leave as a H plus, means what will remain over here? The thing, I'm not going to show this hydrogen again. So here there is a Cl and the negative charge which is remaining over here, means in this case what is forming minus H2O, OH and H. This is what is being formed. Now there was a Na plus, there was a Na plus still in the reaction mixture, right? And here there is a formation of the negative charge. I have shown this negative charge, right? Means there was one electron of the carbon and another electron of the hydrogen together. I can write this to be a one negative charge. Okay, negative charge, or I can also show this to be a lone pair of electron. I'll use different color. I know video will go little long, but mechanism is such an interesting mechanism that you will really feel worth attending to this lecture. So this is the pair of electron. Now, which direction this pair of electron is going to move? It is going to move in this direction because this carbon is attached to halide, and if you see, if this carbon is attached to halide, I will just show a different type of bond, showing it in this way or other way. It is one and same, so that my mechanism explanation becomes more easy. Here also I'll do the same thing. Okay, it is going to go because this carbon is partially positive, it is attached to the halide. See, whenever anything is attached to a halide, the connecting carbon becomes positive, partially positive. So if this is going over here, means it is going to form new bond, isn't it? If that is forming a bond, means old bond should break, and we have to identify the weaker bond. The weaker bond is a carbon chlorine, or I can say that at this stage a chlorine. This chlorine will live easily because chlorine is very good living group, very good living group. Means what is happening here? Finally, what you get is a such type of intermediate, which is also called as a benzene. Benzene. Now, what is benzene? Benzene is unstable. Unstable. I can say very unstable. Reaction intermediate. This is reaction intermediate, right? This is what the benzene is. Further, I'll take this benzene. Further, I'll write here. I'm continuing. So this is benzene, which is reacting with a OH minus. Here there is a base. Actually, we should take a two equivalents. Okay, the base what we are adding over here, it should be 2 moles of NaOH. Sorry, yeah, 2 moles of NaOH. That is what we should take over here. And again, base I am adding. Now I will show you the attack. See the attack. See the attack of this. It is attacking on this carbon. Okay, either this or this. It is one and same. But you may get a question why this OH minus is attacking on this car. Why not on this other carbon? Why only this carbon? See the hybridization of this triple bonded benzene. I will explain you over here. The hybridization over here, this is a sp2 carbon. This is also sp2 carbon. All these are a sp2 carbon, right? But only these carbons are sp hybridized, triple bond. More the percentage of s character, more is the more it can attract a positive charge, right? So here, uh, more is the electronegative, right? So here, this is going to attack over here on this carbon. So what do we get over here? Again, what we get is this. If this is attacking, so this is the pi bond which is going to shift over here. See, always a pi electrons. See, before breaking any bond, if there are all are sigma bond, breaking will take place. If there is a presence of a sigma bond and a pi bond, then pi bond will just move, right? Pi electron will move, right? So here, this is what the OH is. Here, this is what the OH is coming, and here there is a negative charge again, and I will show this OH over here in this way. OH. Now, having a negative charge on double bond is most unstable thing. To stabilize this negative charge, this hydrogen will be donated over here, and it will next step. What we are having is this means here it will get it hydrogen, and this will be O minus. See, this hydrogen means everywhere there are hydrogen. Even if we don't show this hydrogen, then it is fine. Always remember this. Okay, even if you don't show this hydrogen, then also it's fine. Here there is a hydrogen, this hydrogen. Now further, there is a sodium in the, again the base was added. There is a Na plus over here. Then this further, I will write here. What I am going to get is this. I'm not going to show that hydrogen again and again because it is there always. ONA plus. Now this is what the sodium phenoxide, the second intermediate, the first intermediate, the middle product, what we get. Then here, if this is treated further with a acid, like strong acid, like a HCl, what we will get is this H will substitute over here, and this is what the phenol is. OH and minus NaCl. Minus NaCl means Na and Cl means my byproduct is NaCl. So this is how the mechanism is. Sometimes they do ask a question like how many equivalents, how many moles of a NaOH or how many equivalents of NaOH was added in a dose process. The equivalents were two equivalents, we can say NaOH over here and NaOH two times we needed it, and this is why the reaction mechanism is important. Yes, so this is where we end with the preparation of phenol with mechanism. I hope that you have understood this well. Okay, see you in the next lecture. I'll end this class over here.